So unit rates with complex fractions means that you have a fraction within a fraction when you're setting it up. So if we have a problem like the following, we've got an artist, she's working on a piece, and she is completed 1/4 of a painting in 2 weeks. So it took her 2 weeks to be able to complete 1/4 of the painting. I want to know, what is the rate? What is the rate that she's working at? So rate is another way of speed, like how fast is she completing this piece. Now remember, I told you guys on Friday that when you are, okay, on Friday, I told you guys that when you're setting up a unit rate, there are two things that were very unique when you set up a unit rate. Price. Price was a unique thing because price would always go on top. Time, the measurement of time, is also unique because time always goes on the bottom. So I'm going to go ahead and circle 2 weeks. Unless it's otherwise stated. Sometimes it will state, oh, we want to know weeks per whatever. That's the only time that you would do it out of order. If it is not stated, then weeks or time, the measurement of time, would always go on the bottom. So time always goes on the bottom unless otherwise stated. So if they mention it differently, then you obviously go with how they mention it. But because of the fact that they're wanting the rate, the speed that she's working at, the time is going to go on the bottom. So when you set this up, we're going to set it up as a fraction. 1/4 is how much she's completed in 2 weeks. That's called a complex fraction. You have a little fraction within a bigger fraction. Now, just like any unit rate, in order to be able to find the rate, you divide both the numerator and the denominator by whatever the denominator value is. So I'm going to divide 1/4 by 2, and I'm going to divide 2 by 2. It does not matter that it's got a fraction involved. It's still the same process. So if I do 1/4 divided by 2, that's going to give me 1/8. So that means that you've got 1/8 completed in 1 week. That's the rate that she's working at. Let's try another one. Camila filled a 4-gallon bucket in 1/6 of a minute. So she's got the water running, she's filling up a bucket. The bucket is a 4-gallon bucket, and it was able to be filled completely to the top in 1/6 of a minute, which is basically 10 seconds. So again, I want to know, what is the rate? So how fast is she filling up that bucket? Again, where will time go unless it's stated otherwise? The bottom. Time will go on the bottom unless otherwise stated. So 1/6 of the minute is going to go on the denominator. My 4 gallons, that's going to go in my numerator. So I'm taking 4 and I'm dividing it by 1/6. So again, to find a unit rate, you divide both the numerator and the denominator by whatever your denominator value is. So if we do 4 divided by 1/6, that's going to come out to 24. So that represents 24 gallons, because again, you want to refer it back to what the problem is about. That's 24 gallons per what? per minute. Good. When it comes down to a test or a quiz, you have to know how it relates to the unit. You're also going to have problems today in which you're going to be doing some comparisons. So they might give you two ratio values and you need to identify if they're equivalent. And the only way that you'll know if they're equivalent is their unit rate. If their unit rate is identical, then they're equivalent ratios. So let's say that we've got Tim. Tim has 4 apples and 8 bananas. Okay, Alex has 3 apples and 6 bananas. I want to know if these are equivalent. Are these going to be equivalent in ratios? If not, then who typically would have more in comparison? Okay, so what I first need to do is set them up as a ratio and find the unit rate. So we're finding 4 apples to 8 bananas versus 3 apples to 6 bananas. So comparing to see if they're going to be the same. Well, what's 4 divided by 8? Nope. 4 divided by 8. Huh? A half, 0.5. It's just 0.5. 8 divided by 4 is 2. But 4 divided by 8 is a half. What about 3 divided by 6? What's 3 divided by 6, guys? Another half, right? 0.5. So are they equivalent? Yes. Okay, they are equal to each other. They are equivalent. All right, let's say that we are going to spend $12 for 15 pizzas. They're really crappy pizzas. That's why they're so cheap. Okay, $12 for 15 pizzas. You got $10 for 12 pizzas. I want to know, are they equivalent? If not, which one would be the better deal? Okay, so we're going to, again, do the exact same thing. We're going to set it up where it's $12 over 15. We're just going to do 12 divided by 15. When we do 12 divided by 15, it comes out to what? 0.8. So as money, that would be 0.80. That would be 80 cents. Okay, so 80 cents per pizza. Okay, for this one, we would be doing $10 divided by 12. So what's 10 divided by 12 going to come out to? 0.83, right? So that'd be equivalent to like 83 cents per pizza. So are they the same? No. Which one's the better deal? The 80-cent one, right? So the $12 for 15 pizzas. Okay, so this one is the better deal because it's cheaper. Remember, we talked about that. If you want a good deal, you're going to go for what's cheaper. Although if you're getting pizza for that cheap, then you probably might as well just throw up instead. So, all right. Your IXLs. You got 4 of them. They're all listed on Google Classroom already. Go ahead and get working on that. Remember, SMART score is a what, guys? 70. So get to that 70. Move on to the next skill. Make sure you are working quietly.